Your second method today to evaluate higher order polynomials, this is the same polynomial that Mr. Edwards has to do, the one I already did. I'm going to show you a way called synthetic substitution. Okay, synthetic substitution is a different way, hopefully, to get the same answer, and then I'll let you decide which way is easiest. So here are the steps for synthetic substitution. First of all, the number that you are plugging into this function is going to go in a little special synthetic substitution box. I'm just going to call it that, okay? Next to that, we are going to put the coefficients that are in front of these variables, as long as they're in descending order of powers. That means it's going down by 1 every time, 4, 3, 2, 1, and none of them are missing. If there was one missing, we would have to put a 0 in its place, and I'll show you what I mean at the end. But once we do that, we're going to ditch the variables altogether and just put the coefficients. So 4, -5, 3, -1, it's invisible, and another -1. Next, we're going to put a line underneath these, like a normal addition line, because that's what we're going to end up doing. And here are the steps. Step number 1, the very first coefficient, the very first number, just drops to underneath the line. Nothing to do there. Easy. Next, we are going to multiply our special number in our box, 2. We're going to multiply it by the 4 and put the answer underneath the next number. 2 times 4 is 8. Next, we add going down. So I'm going to add going down. I'll get -5 plus 8 is 3. And then the whole process starts again. I'm going to do that number in the box times the number I got here, placed underneath the next number. 2 times 3, 6. Add going down, 9. I can put a little addition symbol here to remind me I'm adding going down. 2 times 9, 18. Add going down. 2 times 17, multiplying, that's 34. Add going down. Not a magic trick. This is fancy math here. But that last number we get is the exact same answer you would get if you plugged in a 2 for all your x's. In fact, it's the same exact answer I got when I did it by hand using my calculator. This is called synthetic substitution. If you have to go back and watch this video again to get the steps down, be my guest. What I wanted to mention earlier was if you happen to have a a polynomial that goes 4x to the third plus x minus 7, the terrible 3 to the third. Notice it goes from x to the third to x to the first. It's missing that x squared in there, and we would need a 0 placeholder. So if I was to evaluate this for f of 1, 1 would go into my box. I would ditch the variables and just put the coefficients 4 for x cubed, 0 for x squared, 1 for x to the first power, and -7. Then I could go about my business, putting my line, the first one drops, multiply 1 times 4, put the answer here, add going down. Multiply 1 times 4, put my answer here, add going down. Multiply 1 times 5, put my answer here, add going down, and then the final number I get is my answer. That's exactly what I would get if I went up here and I plugged in a 1 and ripped it through my calculator. I would get a -2 for my answer for this one. This is called synthetic substitution. Not too bad. Moving on.